word cycle is related to the word circle, so you can think of going in a circle as repeating yourself. This is exactly what the word cycle means in reference to the AC waveform. Let's look at a second important term associated with AC, frequency. The number of cycles generated in 1 second of time is called the frequency of the wave. The word frequency is related to the word frequently. Frequency indicates how many complete cycles of a sine wave occur in 1 second.
The frequency of a sine wave is measured in hertz, abbreviated with a capital H and a lowercase z. For example, a sine wave that completes 2 cycles in 1 second is said to have a frequency of 2 hertz. A sine wave that completes 5 cycles in 1 second has a frequency of 5 hertz. The symbol for frequency is a lowercase f, which represents cycles per second.
Understanding frequency is important because the electrical equipment that is powered by alternating current requires a specific frequency in order to function properly. There are many different frequencies. You can find many of them represented on the frequency spectrum. Let's examine it.
Notice 0 hertz, or DC, at the far left. Thereafter, moving to the right, all of the frequencies are AC. The low frequencies, those between 10 hertz and 1 kilohertz, are used for power transmission. In Europe, the frequency standard for power transmission is 50 hertz, while in the United States, it's 60 hertz. Note from the chart that audible frequencies, those that you can hear, are in the range of 20 hertz, a very low sound, to 20 kilohertz, a very high-pitched sound. Moving further along the spectrum, you come to higher frequencies used for television and radio. VHF, or very high frequencies, are those in the range of 30 megahertz to 300 megahertz. While UHF, or ultra-high frequencies, are those in the range of 300 megahertz to 3 gigahertz. Notice, too, that higher frequencies are used to transmit radio waves. Within these ranges are AM and FM radio. Notice from the frequency spectrum that at even higher frequencies, physiological action takes place. Infrared or heat waves, visible light, and ultraviolet light can be thought of as very high frequencies of electrical waves. As you can see, a further increase in the frequency results in radiation, such as X-rays, gamma rays, and cosmic rays. All of the technologies represented on the frequency spectrum, then, have a common thread. They are characterized by signals that are AC in nature.
Let's consider a third important term for AC waveforms, the period. The time it takes to produce 1 cycle, which you can find along the horizontal axis, is referred to as the period of the cycle. It's measured in seconds. The symbol for a period is a capital T, which stands for time. The higher the frequency, the shorter the period. If the frequency is 60 hertz, or 60 cycles per second, then 1 period, the time it takes to produce just 1 cycle, would be 1/60th of a second. The period of any given AC cycle can be determined by dividing 1 by the frequency. The formula reads T equals 1 over F. Become familiar with these 3 common AC terms.
Let's look at some different ways that an AC sine wave can be measured.
To do this, an oscilloscope will be used. The most apparent measurement of an AC waveform is its amplitude. This is represented by the vertical deflection of the waveform from the baseline. It indicates how far from the zero reference a positive or negative peak extends. The peak voltage is the maximum voltage on a positive or negative peak. It occurs at 90 degrees and at 270 degrees. The peak-to-peak voltage is the distance from the positive peak to the negative peak. It is twice the peak value. A third designation is the instantaneous voltage. This can be a measured value at any one particular moment of time along the AC waveform. It can be found anywhere between 0 and the positive or negative peak.
Stop the program and complete activity number 2. When finished, continue watching the program.